Namaskar and good afternoon to all. And Pile, I would like to thank South Gujarat Local Center Chairman Dr. Jignesh Vagasia sir for doing along with his Under Secretary Professor Ketan Kumar, doing a very great activity, especially in the mechanical division board side is concerned. And I would like to place on record our appreciation from mechanical division board for doing a very useful and very present related topics are selected for the your webinar programs there. And respected President and CARTE Chairman in absentia, and Mr. Dhinath Akhela, competent person for inspection and certificate of boiler, Central Boiler Board, New Delhi. Mr. Umesh Mate, Manager Projects, Magellan Pneumatics Private Limited, Nagapur. Moderator of the session, Mr. Kirti Hirlal Setna, Immediate Past Chairman, South Gujarat Local Center, IEI. Again, Chairman Dr. Jignesh and Professor Ketan Kumar D. Panchal, Under Secretary, South Gujarat Local Center, corporate members, participants, and all mechanical engineers who are attending this program. A very good afternoon to all of you. The Institution of Engineers India, since its inception in 1920, has upheld the mandate of promoting and augmenting the science, practice, and business of engineering through different technical activities and providing meaningful insights to the policymakers regarding matters related to engineering profession, imparting engineering education for working community in non-formal mode, fostering national and international cooperation in engineering and technology, dissemination and sharing of engineering and technical knowledge through activities on contemporary topics, and encouraging, elevating, and recognizing the technical knowledge and practice of individuals and organizations through scholarships and awards. Further, standing at the crossroads of a century of a glorious existence during the global pandemic, IIA felt it appropriate to rethink, introspect, and disseminate ideas, concepts, and the best practices in the emerging areas of technology and engineering through virtual platforms, which finally have evolved into an IEA technical webinar series. Today, we are all excited at the prospect of listening and gaining insights from the panelists of the session on the topic environmental legislation, issues, and challenges in thermal power plants in India. Power generation in India has increased manifold in the recent decades to meet the demand of the increasing population. Coal is the only natural resource and a fossil fuel used widely as a thermal energy source. In India, a major percentage of installed capacity for electricity generation is produced by coal-based thermal power plants. Combustion process converts coal into a useful heat energy, but at the same time, produce greatest environmental and health concerns. Combustion of a coal at thermal power plants emits mainly carbon dioxide, sulfur oxides, nitrogen oxides, airborne inorganic particulates like fly ash and suspended particulate matter. High ash content in Indian coal and inefficient combustion technologies contribute to India's emission of air particulate matter and other trace gases, including gases that are responsible for greenhouse effect. Government of India focused on reduction of emission from coal-based thermal power plants. The Minister of Environment, Forest and Climate Change has issued a notification with the objective of reducing emissions of suspended particulate matter, sulfur and nitrogen oxides, and mercury at thermal power plants. As per the notification, it has become compulsory to install flue gas desulfurization system in the existing and upcoming thermal power plants to curb emissions. FGD is a system which reduces the sulfur oxide in the flue gas through chemical treatment and converting the captured sulfur oxide into gypsum and calcium sulfate or sulfuric acid depending upon the type of mechanism used. I believe that IEA technical webinar on the pollution caused by thermal power plants, the associated challenges and the environmental safeguards being organized by the South Gujarat Local Center of the institution under the aegis of Mechanical Engineering Division Board of the institution today will be relevant for the practitioners and researchers. Hope that the fruitful deliberation will be successful in focusing different aspects of environmental degradation caused by thermal power generation and remedial action. Before I conclude, I would like to invite all the participants and especially from a South Gujarat Local Center, all the engineers for a mechanical convention which is going to be held at Hyderabad in the month of December. already brochure has been released and the papers can be presented, and you can recommend any eminent engineers to be honored on that day for a national awards. With this, I wish again the program, and we are eager to wait to listen from the experts who are here to address us. Thank you very much, Chairman sir. Thanks a lot.
Hello, good afternoon. I am Kirti Sedda, past chairman of South Gujarat Local Center, Surat, Gujarat. Today's seminar is arranged by ourselves regarding the environmental legislation rule, issue and challenges in thermal power plant. It's a very good topic and it was totally connected with the thermal plant, and without that thermal plant, we cannot have produce electricity. There are alternate route is hydraulic power station is also there, wind velocity also there, and solar is there. But original and cheapest way and safe way is only by the thermal power station we get the electricity. Now regarding the topic, I will say that for 50 years there were thermal power plant having a lot of problems, and with their efficiency they were not getting, and black smoke coming out from the chimney. Now, by improving the efficiency, we are not getting. So now improving the efficiency and looking the environment, we have done a lot of work and tried to put all environmental measures they have provided, just like back filter, dust collector, ESP, everything installed in the chimney, and now only the hot gases are going out. The gases are very hot, also recover heat also recovered by heat transfer with the hot air, and whatever air is to be put down in the boilers are preheated by the stack emission heat. Now I will say that what are the issues by burning of coal or other things and producing the electricity. Lot of NOx, NOx, SOx, CO, CO2 and other gases are produced and that gas are emitted. Suppose anybody burns plastic and other things, it creates the furan and dioxin, generated furan and dioxin gases, which is very harmful for the body because it is not soluble in water. So whenever the dioxin inhaled by the person, it will that all the organs of our respiratory system damaged very badly. In bad condition, we come into that. So furan and dioxin is the most toxic gas. NO2 and CO2 is also harmful. CO should not be there because suppose CO inhaled by the person, it's a sweet gas and it's a silent killer. Person will not come to know that what happened and it immediately affected. So whenever the burning, any coal or anything, we have to take more and more care. We are not only behind the producing the electricity and have all these things. No, but we have to look up to the environment because by environment is badly damaged by our all the people by developing all the industries and technological. But we have to take care of environment, and so the boiler rules come down in 1923 and all the boilers should be passed because the hazards are there. It's a human safety and explosion also take place. So boiler government has nominated all the boilers inspectors and everything. So they will check once in a year all the boilers, they test hydraulically. So there should not be any accident. Recently, one boiler exploded in our Surat area, and around 7 to 10 people injured, and 2 3 are very serious. So boiler is very important because whenever it produces the steam, so it's a compressed. Whenever it explodes, it's a more than 100 times. So whenever it the explosion take place or boiler bursts, then immediately surrounding area 100 to 50 to 100 square meter area will be affected very badly. So boiler norms is stipulated. Even air emission from the boiler stack also stipulated by the pollution control board. That is state, local or state and national central also. Now I will give some brief introduction regarding the panelists. And regarding this seminar, the coal is used in the thermal power plant, probably associated with its thermal power plant are air pollution causes due to the burning of coal. Burning of coal emits gases like carbon dioxide, sulfur dioxide, nitrogen dioxide, which are very harmful to the living. Now, whenever we operate the boiler, we have to see the SPM because by burning of coal, some dust particles of the coal is emitted air. So SPM, SOx, NOx to be checked. Since the sulfur emission are proportional to the sulfur content at the fuel. All the coal having around 4% sulfur is there. So by burning of sulfur or coal, it produces SOx, SO2, SO3, etc. So whenever it comes contact with the water, it produces sulfuric acid. So whenever our chimney is made of as MS or cast iron, it corrode within a period of 5 years or 10 years, depend upon the generation of SO2 and SO3. If the sulfur trioxide generation is more, then we have to do some treatment at the air emission of the boiler. So implementation of the FGD of the minimizing generation of SOx user has big problem from the capex or the opex. The base equipment suppliers compact and design and with the loss of everything. Regarding the operation and cost and everything will speak by our panelists. Now I give introduction regarding the panelists. The panelist number one is Dinana Thakile, having the more than 13 years experience in this field. Presently he is working as a manager operation in Hazira, having having the experience of the erection and commissioning of the operation in boiler. He is also he has operated number of boilers and working in boilers since 13 years in Hazira, as well as he has started his career from Pune and having a lot of vast experience regarding the boiler operation. He is also very much worried about the whatever the air emitted or gas emitted from the boilers, and it should not pollute more. So he always insists to having the control measures to be installed at the time of boiler installation. Our second panelist is Umesh Mate. He is also having more than 13 years experience and he has passed out in 2009 from Durgapur, and is also having the operated number of boilers and having the vast experience, and he has also submitted a number of papers and into 210 megawatt thermal power plant simulator conducted by the NTPI Nagpur, and it's a fighter cards. So our both the panelists having the vast experience regarding the boiler operation, whatever the regarding the environment and how environment to be protected. I'm sharing something. I have visited abroad and I have seen in USA and Canada, they are also very strict regarding the air pollution. And their operation point of view, we see that they are also very strict for the operation. Suppose a person is from India, they are throwing everywhere, here and there, they are spitting and they are putting all the garbages. But whenever they visit abroad, their rules and regulations are very stringent, and by afraid of the penalty, they are not throwing anything in the open. So whenever we want to talk about the safety and hazards, that everyone has to follow all the rules and regulations, even in our India also. And whenever, or suppose the person is working or operating boiler in big city or small city or in town or village, he has to follow and behavior based safety. Means they must have to use earplug, dust mask, and spectacles also whenever you operate the boilers. Now I will allow Dinanath Akele to speak regarding the boilers and everything. Okay, all the best. Thank you.
So, a very warm welcomes to all the participants, and it is very nice opportunity that always showing the confidence and support from local centers from Surat, Gujarat. And also would like to thanks to our Ketan sir and Jignesh Bakaria sir and Iti Ranga sir for giving me opportunity to speak about the environmental legislation challenge opportunity in thermal power plant in India. Yes, it is a what we can say the very more concern, and now we have worry about the what we can say it is in the process, because right now what we can say in this regards, we have going to the what we can say the stringent norms regarding the pollution control boards. The after what we can say then regularly they are going to reduce the limits, right? So in that category we have to how we have to get our optimum output from the boilers, optimum from the power stations, and apart from what we have to follow our the rules, and this is given by the central what we can central pollution control board now. So all the things I'm going to deliver here. So definitely this session is going to be more and more fruitful as a point of environmental legislation and challenging opportunity. First of all, I'm going to brief about this event and this what we can say this session in the three category. First, I'm going to deliver about the legislation part of this environmental norms. After that, my ex-colleagues from the Thermax, Mr. Miss Mate, will go to say about the how the desoxing system is going to work. After that, again, I'm going to take the session about the SPM, CMS, and the NOx generation, and what are the lucrative way we have at present with our system that can be utilized, right, to reduce the what we can say the environmental pollutions. Like just we can say about we have about the biomass, right, implementation. So how this biomass is implementation is going in the what we can say as a green fuel, and in the what we can say in our road steps the hydrogen fuel is also there, right? So how the hydrogen fuel is going to be contribute in the lucrative manner for this environmental aspects. So all I'm going to describe. So just with me, I'm just connecting to sharing my slides, right? So I'm very happy to see all of you and in a good number. So you all are very grateful. What we can say the participants. So just please with me. I'm just going to operate. Just going to share my screen. Meanwhile, what we have the questions regarding these sessions, please you can also put in the chat box so that after the end of the session, I will take all your questions. Now, so as part of the what we can say the legislations, yes, we are what we can say the maintained, and we have described the numerous legislations for in the specs. So what right now, because right now I am just observed and just noted that the good number of participants from the abroad, they also have joined the session. So right now, what the norms we are following in India, right? So in that point of view, I'm just going to share the content, right? So in this, what we can say, agenda of the sessions of the legislation, I'm going to talk about the history of the legislation, what and how we have started the this environmental legislation journeys, and after that, what are the some international obligations are also there, and what we have the National Environmental Tribunal, that is Act is 1995, and apart from the last year, what we have the some amendment is also added in this sessions, right? So all the things one by one I'm going to discuss about, but first of all, I am first of all I'm giving the congratulation to all our countrymen that sharing one information that we have proudly say that we have achieved the fifth, what we can say, the largest economy in the world. So definitely it is what we can say the great moment for us. And with this we have the some challenges is also we can say we have to face in this regard, because right now just I'm going to share about this what we can say the power sector scenario right now in India. So we have the what we can say fifth rank, right, in the power generation. So total capacity right now, what we can say 375 gigawatt, right? So this is the data is not what we can say the current data. This is the declared result data from the what we can say the electricity authority of the India, and their forecast what we have gone through that they given that it is going to increase by the electricity demand by the 7%, as we know that our economy is going to be boosted, right? So we have just what we can say increased to the fifth level, and we have just what we can say the UK is just behind of right now the behind of the India. And our energy intensity of the sector projection is 59.79 million ton of the oil equivalent USD by 2030. And as we talk about the PAT cycle, yes, we have also definitely who has not about aware about the PAT cycle, then this is what we can say performance achieved rate, and this is governed by the under the Ministry of Power and Bureau of Energy Efficiency by Government of India. So right now the power cycle PAT cycle 3 and 4 is running, right, and we have declared the result of PAT cycle 1, right. In this we have achieved the 3.06 million ton of the oil equivalent we have saved, and it is what we can say the part of the 0.46% of the Indian GDP, right. And right now what we have the energy consumption per capita is 0.44 ton of oil equivalent. So these all data are going to show is about that our economy is increasing as the demands of the electricity is going to be higher and higher side, per capita consumption is going to be higher. But if we talk about the pollutions, yes, so the three main factors are here. First is what we can say the industrialization is going on. Second is about what we can say the what we have the natural resources that we are using what we can say in the very excessive manner, and very wastage is in the higher side. And the third is also going to be important about the urbanization. So these three factors are going to contribute about what we can say the most in the environmental the pollution. So how with the growth of the economy of our country, how we have to cope up with that? For that, it is definitely necessary that we have to maintain and we have to have forms the good regulations and the good, what we can say, the disciplines. In that category, we have the constitutions we have. In the constitution part, we have the provision for the environmental safety and environmental protection. So, as per the article, this is our Indian Constitution's Article 21, is going to say about the right of pollution-free environment. Yes, it is the right of every Indian that they have to survive, they have to live in the pollution-free environment. The Article 48 tells about the state shall endorse the protect and inform the environmental norms to safeguard of the forest and wildlife of the country. So, as we know that we have the different states, so every state is independent to form their environmental pollution, environmental norms, so that depends upon their geographical conditions, they can made and they can protect it. Second, as per in the Article 51 of the our Indian Constitution, they have told about we have also the duty. Yes, the duty of the every citizen of India that we have to protect our nature, that we have to protect our natural resources, we including the forest, lakes, rivers, wildlife, so that what we can say our whole environment must be protected and must be safe. So, as we talk about the beginning, how we have to started this journey. So, in the Constitution of India, in the Part 3, it is mentioned in the fundamental rights, and in that Article 19 and 21 is going to tell about the what we can say we have to live, we have to do the business, right? We have to practice any businesses, but it does not goes to the what we can say produce the wastage, which is going to in the long terms, it is going to harm the society. Next is about we have also abide with the what we can say the environmental norms with the international obligation that is going to be talked in the Article 51C. So this Article 51C is going to tell about that we have also follow what the standard, what the guideline mentioned in the international forum. So just I'm going to talk about the one forum of what we can say in the Stockholm Declaration 1972, that this is going to tell about the whole the world is having one environment. So definitely it is going to we can accept these things with the heart, right? The whole world is in one environment, right? So accordingly we have to think and accordingly we have to act to save to each places. Suppose I have to do I have to protect the environment at my place, my area, and similar way we have to protect the all, then definitely we are able to save the environment of the world. So for that, in the article, in the Constitution of India, in the Article 51 say that we have to follow and implement the framework to save for the environment. It means it is this article is giving and empowering our country and our what we can say our parliament, that they can frame the regulation, they can establish the regulation in which direction through we can save the environment, we can save the century, we can save our natural resources. So this is shared in the Article 51C. Now, in the general, how we have to start it. So first, this international forums in 1972. After that, in 1986, the first what we can say the Environmental Protection Act came, and the central government to protect and improve the environmental quality control, reduce the pollution from all source prohibited to restrict the setting and operation of any industry facility on environmental ground. In the further, we have little bit move further, and in 1989 the objective of hazard waste. So we have said now we have little bit go in the deeper that how the hazard waste are we have going to control, manage and handling. So this is going to framework that is going to keep the focus about the how these hazardous waste are going to be generated, how we can the standard practice, global standard practice, that how we are going to collect, how we can treat, and how we are going to what we can say the storage, or what we can say the dispose, right? So this all are going through the formulation as per in the 1989 regulations. In the same in 1998 we have framework for biomedical waste, right? So in these rules, the legal binding on the healthcare institutions, hospitals, to streamline the process of proper handling and of the hospital waste, such as what we can say the disposal, collection, and what we can the treatment. In 2000, the municipal solid waste rules came in the picture. He has going to emphasis and empower about the local authority. It means on the municipal authority, they are responsible for collection, segregation, storage, and transportation, process, and disposal for municipal solid waste. So I'm just going to add one important aspects that on this basis we have to courage and appreciate the work of the municipals. We have all across the nation. We do the what we can say the who is the clean city in the clean city in the India. So I'm just going to disclose from here that last 2 to 3 years, as per my best knowledge, always the Indore are getting the first prize, right? So this is the such a what we can say the such forum, such programs we have initiated, so that on the municipal level, on the city level, we can make this arrangement that all the municipal solid waste must be properly in line, right? So this is the way right now we are practicing, that we can say that in every society and in every houses we have municipalities providing that one is what we can say the wet garbage, and one is your dry. In this way we are going to start from the home, right? So that this work is going to be easier to handling and segregation process. In 2002, we have also implemented about the noise pollution, right? So the noise pollution, so that it is not going to reduce the noise level and permit use for the loudspeaker or public addresses during the night hours, or in any culture or religious festivals occasion. So we have limited for that. So this the things we have implemented, the what we can say the norms in the category, in the context of the environment. If we talk for the forest and wildlife, in 1922, the Indian Forest Act and Amendment 1984 has implemented is about that how we have relate to the forest, transit, forest produce, and what we can say the level of the timber and other forest produce. So in 1972, Wildlife Protection Act 1973, amendment in 1921, it is talking about the protection of the birds, animals, and all the matters that are connected to it, whether it is their habitat or what to hold for the forests that sustain them, right? So in 1980, we have again implemented for the Forest Conservation Act and rules in 1981, provide the protection of and conservation of the forest. In 2002, right, we have the Biological Diversity Act, right, that is going to provide for the conservation of biological diversity, sustainable use of the component, fair, equitable share of the benefit arising to those the biological resources and knowledge associated with that. As concern of the water, so 1974, the Water Prevention and the Control of the Pollution Act established. That is also what we can say is going to regulate through the Central Pollution Control Board through Delhi. 1977, the water assess, this is the tax provided to refer and collection of the assets and free on water consumption industry and the local authority. So these things we have to implemented so that we can reduce the wastage of the water. 1978, the water access rule contains the standard definition and indicate the kind of the local of the meter that every consumer of water is required to affix. So that thing we have implemented, that how much is actually needed. According to that, the meter is going to work on the local basis. 1991, the coastal regulation zones notification put to regularization on the various activity, including the construction. It gives some protection to the backwater and the seas. And in 2010, the wetland rules also came in the picture. As concern of the air, so lots of also we have worked in this regard. 1982, the air rules define the procedures of the meeting of boards and the power entrusted to them. 87, the Air Amendment Act empowered the central and state pollution boards to meet with the grave emergency of air pollution. Yes, so that's why in India we have not only dependent upon what we can say on the central pollution board, but every state has its own authority that according to they can establish the rules. In 1986, we have the Environmental Protection Act, so we have figured out, and in this we have improved the water, air, land, and interrelationship with existing between the water, air, land, human being, and other living creatures, plants, microorganisms, and properties. Environmental pollutant means the solid, liquid, gaseous substance exist in the concentration as may be tends to be injurious to the environment. Environmental pollution means the presence in the environment for any environmental pollutant. Apart from how we have the handling, how we have the storage and collections, that also we have make up the frames and network through which we are going in the process that we can protect the environment. So these all are written, documented, and written practiced accordingly. The framework has been given, and through their guideline we are following. But the requirement under EPA, Environmental Protection Act, the Section 7 is also talking about no person carry on any industry operation, process, shall discharge, emit, or permit be discharge emitted by the environmental pollutant access of the substance and may be described. It means what we are doing the practice, what we are having the profession, what we have the businesses, and that is not going to harm in the short time and long term as a adverse effect of the environment. Section 8 told about no person shall handle cows handled by the hazard substance except in the accordance with the such procedure after the compiling with the safeguard may be prescribed. So suppose some the businesses or some authority are using the some hazardous material, like somebody are involved in what we can say the X-rays and other hazardous things. So they must follow the procedures, right? So they have to go through the procedure, and their procedure they have to follow and proceed for the forward. Apart from that, in India we have the National Environmental Tribunal Act 19. So in this act, what the things is going to be strict liabilities for the damage arises out of any accident occur while the handling any hazardous substance for the establishment of the National Environment Tribunal for active and present disposals of the cases arise from the such accidents with the view of giving the relief, compensation, and damage. So this is going to act about some what we can say some sometimes the cyclones are coming and some natural calamities are coming. In that way, it is going to be more effective. So that is coming in the category of the National Environmental Tribunal Act. Apart from that, we have also established the system of the appellant to the authority. This act is going to empower for establishment of the National Environment Appellate Authority to hear the appeal with respect to restrictions of area in which a industry operation process, class of industry operation process are not carried out or shall be carried out subject to certain the safeguard under the Environmental Protection Act 1986, right? And matter connected therewith or accidental thereto. So in this way, we have the authority that we can apply and we can appeal for the what the things are going wrong. So this is the what we can say the brief detail about the environmental legislation in India, right? So now I'm just going to hand over to my ex-colleague Umesh Mate. He's going to deliver about the what the systems that is we call the DNOx, DSOX. DSOX systems is going to present about, and after that I'm again going to take the session for the how the we are going to control about the SPM and how we are going to control about the NOx and what the lucrative benefits are present that I'm going to present in my next next sessions. So welcome Umesh.
Thank you, Dina. Good afternoon, everyone, respected dignitaries and my friends, all the participants. Thanks for giving me the opportunity, this platform. Okay, so my topic actually this is the DSOX. So before starting the DSOX, let me give a brief introduction about myself. I am Umesh Mate, and I have passed out from National Power Training Institute, Nagpur. I have done BE Power Engineering from NPTI, Nagpur Power Engineering, and after that I joined as a GT in Thermax Limited company and in the boilers and heater divisions, where I have worked for almost 5.5 years in the proposals process department, where I have worked associated with deals where my job profile was to thermal designing of the boiler and process parameters, proposals, all the heat and mass calculations. So, and after that, I joined McGill Pneumatics Private Limited in Nagpur. I'm looking after this. I was in after joining McGill, I was in the proposals department, proposals and marketing department. The McGill actually deals with the bulk solids handling system, material handling system, pneumatic conveying system, and also has entered into the water treatment plant, sewage treatment plant, and infra. So getting diversified in the field of water, wastewater management, water supply, and now actually I am working as a project manager from last 4 years in McGill, looking after the projects of pneumatic conveying system, ash handling system, and bulk solid handling system. So let me start my presentation. I will share the screen. Yes, so desulfurization in thermal power plant, DSOX. So what is actually this? First, let us understand what is SOx, okay, and how it is formed. So basically, SOx is nothing but sulfur dioxide, and sulfur dioxide is formed. Let's say the fuel in the boiler which is fired the fuel contains sulfur. Sulfur content in the fuel in the Indian coal ranges from 0.25 to 0.5%. And in imported coal, it is more than 0.6%. So this combustion of this fuel having this sulfur results in SOx formation, SOx emission. And this SOx is formed by the reaction of this sulfur contained in the fuel with the oxygen, okay, and to form SO2, that is sulfur dioxide. So now why this flue gas desulfurization is implemented? To reduce this SOx emissions, this flue gas desulfurization technology has been implemented. As you know, this, which I have told, combustion of fuel having sulfur results in sulfur dioxide emission. And almost 95 to 96% of the sulfur is converted into SO2. Sulfur content in the Indian coal ranges from 0.25 to 0.5%, and in imported coal it is more than 0.6%. Typically, coal with 0.5% sulfur generates SOx of 1500 to 2000 milligram per NMQ. This SO2 emission results in acid rain, then corrosion of the buildings and structures, and affect human health. I will also detail this effect of the SOx in my further slides. What is the basic principle of the DeSOx, that is desulfurization? Basically, it is a limestone gypsum process. This limestone actually is a agent, is a reagent to suppress the SOx which is formed in the power plant. This limestone is readily available, cheaply available around the world, and the limestone gypsum process performs the desulfurization by eliminating hazardous SOx from the flue gas. This SOx is absorbed and reacts with the limestone, and gypsum is generated by oxidation process. And then this generated gypsum can then be effectively utilized as a raw material for cement, plaster board, plaster of Paris, etc. Now coming to SOx control technology. Basically, we are controlling SOx in 3 technologies. One is pre-combustion zone. This is a typical schematic diagram which I am sharing to you all. Pre-combustion zone, then in-combustion zone, and post-combustion zone. In pre-combustion zone, that is before firing the fuel in the boiler, it is actually pre-combustion zone is generally used to remove the surface sulfur content. Normally, the sulfur content in the fuel is in 2 types. That is surface sulfur content and inherent sulfur content. So this pre-combustion technology is mainly used to remove the surface sulfur content of the fuel. And it is achieved through washing, drying, and then further feeding to the boiler.
Pardon, Umesh, your slide is not moving.
Slide is not moving?
Yeah, it is still in the first slide.
Still it is in the first slide.
Yeah. Just please change so that I will correct to you and update.
Now?
Now it is just to put in the full slide mode. Slideshow.
Slideshow.
Yeah.
Now it is visible?
No, just 1 minute. No.
Your
it is
screen sharing is paused. Oh, okay, just a minute.
First you
stop screen and then I will again share the screen.
yes. First, yeah. Now you go through the, what we can say, the screens here. Now you do the.
Now
do
it
the-
is okay?
Yeah, perfect. Perfect, good. Continue.
Okay, should I go to previous slide?
Yes, you can do 1 and 2 slide and then you can pick up it.
Okay, this actually, sorry for the inconvenience. I was talking about the SOx control technology. SOx control technology, basically we are doing in 3 parts: pre-combustion and in combustion and post combustion. This pre-combustion technology is basically used to remove the surface sulfur content. This sulfur content is the fuel is in the 2 types. That is surface is present in the surface of the fuel and inherent sulfur. So this pre-combustion is used to remove the surface sulfur content, which is achieved through washing, drying, and then feeding to the boiler. This actually normally this pre-combustion technology is used for low capacity unit less than 50 megawatt. The reason is that because the fuel handling capacity is less in 50 megawatt unit. So it is not suitable for large capacity units due to the handling, that is washing and drying of the fuel. Hence this technology got obsolete. The next is in combustion technology. In combustion technology is basically in furnace injection technology. What happens, this limestone is fed into the boiler at a high temperature zone in the furnace. Around 900 to 980 degrees centigrade temperature of the furnace is achieved through burning of the fuel in the furnace. And at this temperature, this limestone is fed in the furnace, and which is used normally in a preferred technology. This is a dry injection system. And the SOx removal efficiency is 80 to 90% in case of CFBC boilers and 60 to 70% in AFBC boilers. Then coming to the next technology, it is post-combustion technology. Post-combustion technology is basically in the flue gas path. This is installed in the flue gas path, preferably after ESP and before ID fan. This technology is basically wet type, wet FGD system, what we call, and with a spray type. I will show the principle of this wet technology in my further slide. Here, SOx removal efficiency is very high. It is almost 90 to 95%. This is the dry injection system, typical schematic diagram of dry injection system. In dry injection system, the limestone powder is pneumatically transported from cement plant to limestone bunker situated in the power plant. And then from power plant, it is further transport is fed to the furnace, and from furnace in combustion technology, the SOx get removed in the process of chemical reactions. Chemically, it got reacts and clean gas removes from the chimney. Yes, this limestone powder transported pneumatically from cement plant to LS bunkers at CPP. And from this LS bunkers, limestone powder get mixed with the fuel and fed to furnace for feeding chutes. In furnace, due to combustion process of the fuel, the temperature of furnace rises to 900 to 90 degrees Celsius. At this temperature, limestone, through particle fragmentation and rapid calcination, convert into reactive CaO, and this carbon dioxide is driven with the water vapor. Further, under oxidizing conditions, this calcium oxide reacts with the SO2 produced to form this calcium sulfate, and SOx emission gets reduced, discharging clean gas in the atmosphere. This is basically a dry sorbent injection system, and which enables plants to remain in operation when the capital cost of a wet flue gas desulfurization is high. The dry sorbent injection initial capital cost is low as compared to wet FGD system. And this injection of this alkali sorbents can also offer other benefits to the plant, including lower operating cost, less corrosion, and reduced activated carbon usage for mercury removal in high SO3 environments. This is the chemical reactions of dry FGD system. First, this process takes place in the furnace through particle fragmentation and rapid calcination. During calcination, reactive CaO forms as carbon dioxide and water vapor are driven from sorbent crystal structure. The calcination of limestone is described by the following reaction. CaCO3 at this high temperature limestone. The calcination of limestone is an endothermic reaction requiring approximately 1861 kilojoule per kg of pure calcium. Just a minute. Yes, this calcination of limestone is an endothermic reaction which requires approx 1861 kilojoule per kg of calcium carbonate. And this calcination rate is the function of type of sorbent and its surface area. The calcination of limestone is very fast at temperature of 990 degrees centigrade or greater. Below this temperature, the reactions are very slow. So it is recommended that the furnace temperature should be more than 950, 980, like that. Under these conditions, the reactions are very fast and very good. Under the oxidizing conditions, this sulfation or sulfur capture is happen, and it is described as follow. This calcium oxide reacts with SO2 and oxygen, generating calcium sulfate. This calcium sulfate is basically a byproduct of this dry injection system, which can be used, be used for the process of the plaster of Paris, because this CaSO4 is having a very good properties of molding when mixed with the water. Okay, and yes, now moving to wet injection system. This is basically this schematic diagram is just a minute. Yes, this is schematic diagram of wet injection system, and this diagram which I am showing to you is basically a scrubber technology. This you can see these socks and the flue gas is coming from the ESP outlet, is enters into the scrubber from the bottom of the scrubber, and being a light, being a density, lower density, it tries to move upward from this gas distribution tray, and below this limestone slurry is there at the bottom of the scrubber, which is pumped through these recirculation pumps, and from this recirculation pumps, this slurry, limestone slurry, is sprayed through these spray levels at the various spray levels, petentites, interstate, interspatial spray levels. This limestone slurry reacts with the SOx present in the flue gas, and further this SOx clean flue gas get emitted from the outlet of this scrubber. This is the reaction of wet FGD system, limestone CaCO3 reacts with SO2 and water to form calcium sulfide, and carbon dioxide removes with the flue gas outside. This calcium sulfide hemihydrate is further reacts with the water and oxidation process forming gypsum. Yes, this flue gas from ESP enters near the bottom of the absorber and travels towards the top of absorber through gas distribution tray. Alkaline slurry is present inside the absorber, which is pumped to the top of absorber via reciprocating pump into the spray level to be sprayed on the flue gas. Flue gas reacts with the alkaline slurry in order to form CaSO3 calcium sulfide. This calcium sulfide is then settled down to the bottom of absorber. Clean gas then goes through the mist eliminators to remove the moisture and finally goes to the stack. At the bottom of the absorber, this oxidized air is passed with the help of oxidation air supply and mixed with calcium sulfate to produce gypsum, which then used for further process. Coming to mass balance, this typically sulfur S plus O2, SO2 you all know. So suppose 32 gram of sulfur and 32 gram of oxygen, so it gives 64 gram of sulfur. I have taken an example, typical example of 125 megawatt coal-fired power plant, where approx 100 TPH of fuel is being fired. So suppose 0.5% sulfur is there in the fuel, and if you fire 100 tons of the fuel, so 0.5 tons of sulfur is content in the fuel is present. And if she suppose the unit is running for 1 year, that is 365 days. So I've calculated total sulfur production is almost 0.5 tons into this number of hours. And SOx is almost double of the sulfur, means 1 kg of sulfur gives 2 kg of SOx. So if you calculate the SOx produced per year in the 125 megawatt coal-fired power plant, it's almost 8760 tons of the SOx which is produced. So you can see how much SOx this power plant is generating, 8760 tons, which is very high. This is the mass balance of wet FGD system. This is scrubbing model, which I have explained in my previous slide. This is you can see flue gas, this SO2, this is a 500 megawatt unit, pulverized coal-fired plant. These are the parameters I have taken for 500 megawatt unit, PF fired, where this SOx generated is 19.1 meter cube per hour. After this scrubbing module, you can see the SOx is almost 90% sulfur capture has happened. And clean flue gas almost 1.91 meter cube per hour, it has been reduced. And this is the makeup water which we have to 68 TPH. This is the mass balance of typical FGD system, wet FGD system. Reactions efficiency. A dry injection system efficiency is around 80 to 90% in CFBC and 60% in AFBC boiler, because CFBC actually is having a long shaft furnace where residence time of the fuel is high as compared to AFBC boiler. Hence the combustion of the fuel and reactions with the limestone is very good and very fast in case of CFBC boiler. Hence the efficiency of this dry injection system is more as compared to AFBC system. Then wet injection system is having a very high efficiency of 90 to 95%. Environmental norms, coming to environmental norms, this SOx is having a restrictions. The units which were installed before December 2003 for less than 500 megawatt unit, it was 600. It is 600 milligram per nm cube, and for greater than equal to 500 megawatt unit, it is 200 milligram per nm cube. Units installed after January 2004 and up to December 2016, same restrictions were levied in the power plants. For SOX, it is less than 500 megawatt 600 and greater than equal to 500 is 200. The units which were installed after from January 2017, the restriction is 100 milligram per nm cube to all capacity power plants. Now, what are the challenges for this FGD system? This weight FGD system basically is a high capex, a high capital cost because of this imported items which we have to import. There are so many items which we have to import and we have from outside, from abroad, and due to the high cost, okay, setup cost is more. So this is a very huge challenge for a weight FGD system. Operational cost is low, then supply chain, strong supply chain for input and byproduct. Dry sorbent injection system, the capex is low, means capital cost is low for setting the this dry FGD system is not that much as compared to weight FGD, but operational cost is high. Maintaining the system is very, the cost is very high. This system is basically dry FGD suitable for older units, and low efficiency, this low PLF which I have told you in my previous slide. Further, the challenges, technology suppliers are mostly situated abroad. Mostly we have to import the items from the China's and other German for installing this FGD system, weight FGD system. Indigenous manufacturing capacity to be developed and ramped up fast. FGD retrofit difficult in many of the older stations due to space constraint. FGD retrofit difficult in many of the older stations due to space constraint because older units is having already it was optimized in the less space, and fitting this FGD is a difficult task. Approx 80,000 megawatt of total installed capacity of less than 500 megawatt units will be affected due to no availability of space for the retrofit. Large consumption of water requirement is that is about 0.25 meter cube per hour per megawatt of water is required for weight FGD. So this is one of the challenge in weight FGD system. The impact on power supply position due to closure of most of coal-based capacity due to non-fulfillment of environmental norms. These are the challenges, further challenges, huge capacity with deadlines. Then FGD market is now developing in India. Recently, just 2-3 days back, I got to know that this FGD system further the date has been extended to from 2022, December 2022 to 2025. Because of the challenges which I have, because almost it is difficult to install the FGD system in this huge capacity power plants. Number of units is a big challenge for us. Retrofitting the FGD, installing the FGD, and in this lesser time, it is a very difficult task. So that's why government and due to this COVID also, so government has again extended this FGD installation to 2025. Now coming back to challenges, limited vendors are available, about 30% FGD items to be imported. Then increasing manufacturing time due to overbooking of suppliers, cost is increasing, funding issue in private plants. Then these are the list of imported items which we import from Germany and China. Recirculation pumps, slurry recirculation pumps, then this oxidation blowers, limestone grinding system, gypsum dewatering system, slurry pumps and accessories, agitators, spray nozzles, spray pipes, all are imported items. Global SOx emission. This is the data in 2018. Total SOx emissions in 2018. You can see India was number one in 2018 for the SOx generation. Approx 4586 kilotons of SOx was generated in India. Second number is Russia, third is China, fourth Mexico and Iran. Now, what is the effect of SOx? Basically, the effect of SOx on environment is when this SO2 combines with water and air, it forms sulfuric acid, which is the main component of acid rain. This acid rain can cause deforestation and also can affect the aquatic life. Acidify the waterways to cause to affect the aquatic life, flora and fauna. This acid rain also results in corrosion of the buildings and structures, then chimneys in the power plant, and further the effect of SOx on health. SO2 can cause respiratory problems such as bronchitis and can irritate your nose, throat and lungs. It may also cause coughing, then wheezing, then asthma attacks, and it has also been linked to the cardiovascular diseases. So it is having a very dangerous effect on the environment as well as on the health of human body. I have also like to share you the cost data to set up this FGD system in thermal power plant. As per available data, this installation of FGD in thermal power plant cost approx rupees 19 lakhs to 90 lakhs per megawatt. Obviously, it depends on the size of the unit, number of units, and the locations, and the system or the technology which has been used. The cost of installing FGD systems in large power plant is largely in the range of rupees 42 lakhs to 53 lakhs per megawatt. Recently, NTPC Vidyanchal commissioned FGD at 500 megawatt, which is unit number 13, at its 4760 megawatt power plant at 210 CR, that is rupees 42 lakhs per megawatt. So we are not very far, and that's all. Thank you.
Thank you, Mesh.
Thank you.
Yes, thanks for the practical aspects and the practical inputs you have provided and the category of what we can say for the SOx, like the heat mass balance, the details, and what the costing right now we are getting, right? So just I have gone through the chat box and the so many questions are here. So definitely we will ask after my sessions, right? But the some of they are going to ask about the mesh that why we have what we can say the mainly dependent upon the imported or what we can say the supplier from the abroad. Why we are not developing the such what we can say scrubbers and systems as an indigenous product. So I think this question is very valid question, right? Because this is the vision of our honorable PM that we have go through the Atmanirbhar Bharat, right? So in this category, why we should not going to develop the indigenous product? So I think you are best able to give the answers to the audience, because the chat box they have lots of many they have asked for that.
Okay. As far as I understand, this list of imported items mainly comprises of this imported means basically the pumps, the slurry pumps which we are importing from the Germany, from China. Mainly, what I understand, the technology suppliers and maybe the cost and the reasons. But we should try. We should definitely we should focus. We should try to manufacture these imported items in our India itself, not having any dependency. So I have to check that what can be done in coming days.
Right.
In India also there are the suppliers. In India also there are many suppliers of the pumps. We have to check whether that pumps are suitable for this. Means whether we can use our indigenous indigenous equipments like slurry pumps are there, SAM Turbo. We can discuss with our vendor. The SAM Turbo is there. Then so many other Warman is there. 2-3 vendors are there for this imported. It is not like that we cannot do. You have to check with them whether they are what issues they are facing, and which we have to approach the OEMs of the items which are going to install in the FGD. And after discussing with them, after having we can take a call to manufacture the items in the India.
Okay.
It's not to having any dependency on the export suppliers, not to having any imported items problem will be sorted out.
Definitely, and hope we will definitely do much better in the coming future and the coming time. That what a technology we should develop as engineers, we can do it. So thank you, ma'am. Thank you, and thanks to all the lovely the participants. Now I'm going to start the other two. The what we can say the factor. The one is about the SPM and other is about the what we can say the NOx. So just with me, I'm connecting with my slides. So just with me. Thank you.
Start. Simulation.
So once again, welcome to all the participants of today this webinar, and thank you to connecting and show the confidence with this II. So myself Dinanath Khera, and again I am going to talk about this SPM and NOx system. So before of that, I'm going to talk a little bit about what we can say the what we have currently the follow. In the regard of this, what we can say the emissions. First, I'm going to target about the emission, right? So the average, what we can say the emission in our country is from 2019, it is growing at a percentage of what we can say 1.4%, right? And the average of per decade, what we can say it is from last decade, it is 3.3%. If we talk about what the government of India and what we have done in India in context of the control of emissions, so first I would like to thanks to the Supreme Court that with their decisions and strict application about the Bharat Stage 4, the BS4 norms has implemented. And the lots of what we can say the advantages and this the emissions problems is going to sort out. The second is about the national solar missions. Yes, because as we talk about the just the era of the last decade, 2015, not 2015, 2005 and 6, the ratio of what we can say the solar and thermal bars, it is in the ratio of 80% and 20%. But right now we have some latest data and some latest the details that this ratio has lots of the differences came out, right? So now it is approximately 67 to 70% of the thermal and 30% reached to right now the operation of the solar energy and the solar plants are going to contribute. Next, that is making the big difference is about the national wind and the solar hybrid policy in 2018, right? So it is also going to this initiation and these initiatives going to help to India to cut off the CO2 emission by 164 million kg. If you talk about what in the last year of the COP 226 and the addressed by the PM, and we have going in the way of the non-fossil fuels, right? And what we can say going to the 50%, we have going to complete the 50% our fuel and energy requirement by the renewable energy by 2030, bring down the carbon intensity and the energy India economy more than 45% by 2030, and cut down by net projected carbon emission 1 billion ton from now of 2030. And we have the targeted of the net zero carbon emission by 2070. So this is what we can say the little bit the what we have the set the target for the next. Now, just I am going to give you the detail about what are the severity of the emission, right? So just I have taken one example of 500 megawatt. That is for coal-based power plant, which is where we are using the domestic Indian coal. And in that category, just I'm going to tell you how it is going to be severe, right? So if we talk about the how much the flue gas emission of flue gas is going to be generated, that is 1760 cubic meter per second. And if we just go to measure on the average values of 100 milligram per normal meter cube of SPM, then it is going to produce the total 472 kg per hour. And if we talk the SO2, and that I'm just going to calculate on the basis of only 0.5% of sulfur in the coal, right? On that basis, if we are going to calculate with the for 2 into 500 megawatt of the boiler, PF boiler, so it is going to generate 8,600 kg, right? Or we can say 8.6 ton per hour of SO2, right? So definitely it is going to harm the society and environmental lots. That's why it is a big concern of the what we can say the Central Pollution Control Boards and the authorized authority. If you talk about the NOx, then it is going to generate to 2.7 ton per hour. So this is the some data. And now what the world is going to maintain and on what the standard we have. Right. So for that, just what we can say, PM means the particulate matter. So in the China, it is they are maintaining. They have the target for the 30 milligram per normal meter cube. SOx is 100 and NOx is 100. So the same we are also a little bit going to maintain in India too. So this what we are going to show. This was the little bit older data, right? So now what we can say the extensions of the deadline for implementation of all the measures, right? So 30 of the SPM, 100 and 100 of the NOx is has the deadline for 2022, but now it is the shifted in the last amendment, which is just in the this month of 5th of September 2022, they have shown, and that is the next date is coming in the 3 phases. So first is in 23, 25, and second is 24, 25, and third is 25 to 27. Right. So based on the what is the capacity, based on what is the level of the their emission, this is the deadline is going to be set. Now, what are the issues are we right now the facing with the regulations and going to implement? So the first things is that is about the this requires the funds, and these funds either we have to go through the cop up with the capex, or either we have to go with the opex, right? But apart from that, if we go through the what we can say the emissions evolution of the emission standards in thermal sector. So first we have in 1984 the PM we have set that is about the 150 milligram per normal meter cube. After that, in 1989 we have set the stag limit, right? So this stag limit is 14 q to the power 1 by 3. We have set it with this formula, the stag height. After in 2022, we used to minimize the SOx and the sulfur, we use the beneficial coal. After in 2003, we have set the limit of 50 and 100 milligrams normal meter cube, and the stag height for additional is 275 meter VFX. In 2015, we have also set the new limits for the SOx and the NOx and particulate molecule on matter too. So this was the what we can say the data for the environmental norms. This is we are going to follow for the for January 2017, but little bit it has to be changed. Some of the participants they want to know about what we can say the mercury, right? They have asked the question in the chat box about the mercury. So just I'm going to tell you about that. The Indian pool is they have very lesser amount of mercury, so that's why this limit is very less. This is in the range of what we can say is 0.03 milligram per normal meter cube. If we talk about what we can say the consumption, the specific water consumption for per megawatt hour is 3 meter cube, and we have set the target. We have set the target for zero liquid discharge, right? Which is again it has implemented in 19th of October 2022. But these all are going to the some good the things is also we have that we all the plants they have to show their emission current value at the entry gate of their plant, and this data is right now connected with the state pollution control boards and the central pollution control boards, right? So this what we can say, just I'm going to add one of the things in just of what we can say last week the government of Rajasthan they have declared that the sum of installations they have achieved that their emission values, real data values are coming with the state pollution control boards. So this way we have to continuously monitoring to every industry that what they have values are going to operate and what their values they are going to maintain. Right. For that, we have some technology. What we can say that is your continuous emission monitoring systems, where this we have applied. What we can say depend upon the capacity and the installations. We put what we can say 1/3 height of the what we can say the chimney, where we will put this CMS, and through this CMS we are getting the data, real-time data. That is about what we can say SOx, NOx, and SPM. So for that, all the things are what we can say. This accessories are there, like the sampling devices, sample conditioners, calibrations devices. All with these are established with this system. So this is here. I have just shown in the picture that here we have put the tapping of this EMS, through which we are getting the regular data to get the monitoring system. This is the what we can say the some data of the what we can say developed country and India, right? So we have advantages of this the CMS. I'm talking about the CMS, about the real-time data we are getting, the remote access of the operator and regulatory, and they are coming on the by monthly or what we can say or in the quarterly basis, so that they can seal the data, they can cross-check, they can what we can say their calibrations reports. They all are set, and based on that they approve the reports. So for that, we have to what we can say the this is the criteria for what we can say the system of the CMS. So that system must be what we can say the robust and must be going to operate for continuous 24 into 365 days, and this result are valid. It should be definitely without any malfunction, without any deviation. It should be work as perfectly. So in the future of what we can CMS, the best available technology that we do for this CMS, the device certification system or lab implementation, holding for instrument supplies and the service partners, uniform display systems, respective of the vendor and the supplier. So this is incorporated with the CMS system. Now, if you talk about the SPM, the suspended particles matters. Then for the details, what we are going to analysis, I have just corrected from the what we can say this from the list from the Ministry of Environment and Forest and Climate change where these details are going to mention, and also there are mentioned about by which method we are going to analysis. So for what we can say for SPM, we have to apply the what we can say the ESP, right? Suppose our existing ESP is not capable with the desired the limits of the SPM, then in that case we have to place the new ESP or we have to add the another field so that our the required standard we can meet. So this is what we can say the predicted emission of 500 megawatt coal-fired power plants with the Indian coal. Just I have noted here. So suppose we have the 500 megawatts. So for that, for per dollar consumption for per ton is what we can say 7,000. So here I'm just going to take the only the Indian coal 100%, and the consumption is the 7,000 ton per day. And average what we can say take the in Indian the sulfur content is 0.27, right? So on that basis, I'm just going to calculate and tell you that the sulfur burning per day is 18.9 ton and emission is 37.8 ton. So because just we know that the S plus O2 it is going to form the SO2. So 32 and 32 it is going to make to the 64. That's why if the sulfur is what we can say the sulfur is suppose is 1, then the SO2 will be the double. So that's why you are observing here the what the sulfur is going to be burned and the SO2 is just of the double of the amount. So based on that, I'm just going to calculate, right? So just please look at here this data that how much SO2 emission is going to in the ppm. So it is coming in 359, right? But we have the set the what we can say the limits right now. This is what we can say the 200 for 2016. But as of now, we are following the 1st August 2017 norms, so it should be less than 100. Right. So for that, we have to use this what we can say the FGD or D SOx system. So the measurement of the SOx and the NOx, we have the analyzer systems and which is going to work on the infrared radiations method, and we have take and place this device as 1/3 of the chimney. That depends upon the what we can say the little bit of the size and the capacity of the unit, but generally we can do it. We can take the sample and with the standard we can cross check and calibrate. Now we have why we have the what we can say why it is not going in the smooth ways, because the challenges in the execution, right? The running condition, the plant is in the running, we need the shutdowns, so we need the what the spares and the materials are required, right? These materials are going to import from the what we can say 30%. So this is also going and ordering and the delivery. It is going to the time taking process. The cost is also going to contribute in this process. So that's why this the execution is having the challenges. Right. Another what we can say the factors. So what we have decided, we have to go through the phase wise, right? So that when we have the opportunity to implement during the shutdowns periods, we can implement the systems. The challenges, the plant operating range, the correct measurement of existing emissions, the baseline plant emission, auxiliary loads, heat rate at the different part of the load, availability of what we can say limestone, because in this control, the SOx controls, we use the lime. Optimization of the SOx and NOx greater than implementation of operational flexibility, because we know that if the unit is working on the part load, then it is difficult to judge what the correct amount of this the feeding of the limestone is required. So just if you talk about the time duration, right? For the time duration, it is for the AESP's construction is 3 to 6 months, and the shutdown is required for 20 to 30 days. If we talk about the FGD, 18 to 24, and shutdown required is 3 to 90 days, right? Apart from other, the what we can SCR or non-SCR or low salt NOx burner, it is accordingly it is going to take the 7 to 30 days. Now, I'm going to talk about this the NOx control and the NOx reduction. So for that, we have the systems, and it is going to generate only the what the amount of percentage of this nitrogen present in air. And when our combustion chamber has the temperature increased by 1050 or 1100 degrees Celsius, that time only this NOx is going to be generated. Right. So for that, we have the first is going to be, we have tools is our engineering control, or what we can say the combustion control. In this method, we do the control of the low NOx burner. We can also use the what we can say the overfire damper or overfire port, through which we can dilute the temperature of the furnaces and reduce the emission, or reduce the what we can say formation of the NOx. Apart from the gas recirculation systems, so what the things are required apart from the what we can say the water and steam injection systems are also there. So in the gas turbine, right? So in what we can say in the frame 6B or frame GT frame 9, where we have the steam injection systems or water injection systems, we have incorporated in the what we can say the gas chambers, right? So that we can reduce the temperature of the furnaces or combustion zone. So this is what we can say the some sort of engineering. I can say it is the engineering control through which we are going to stage wise combustion, right? We are doing the combustion, but in the stage wise, so that our temperature within in the profile of 1050 or below of the 1100 degrees Celsius, so that we are at the boundary of the NOx. We are not go on higher side, so that more and more NOx is going to be generated. Apart from that, suppose we have the facility for post combustions. In the post combustion, we are going to dose with the some what we can say the some catalyst like ammonia or some other liquids we are using in the furnace. So how this is going to be implemented and how this is going to what we can say the proportionate, that I'm going to show here. So the fuels NOx, the availability of oxygen and nitrogen content we are using, like ammonia we are using, and in some category what we can say the Thermax NOx is suppose this is going to implement, then in that cases NOx is going to come to into in the combustion chamber, and furnace temperature and oxygen availability is the sensitive. So this is also we have the challenge for the NOx control. That is, first is about the combustion technology, that how we are going to use. So for that, the better is the low NOx burner. Yes, low NOx burner is definitely going to advantage, because we are going to improve the combustion in the stage wise. So this is going to much more helpful. The second is about OFA, overfired air, or what we can do the separated overfired air SOFA. So this is going to implement in what we can say in CABC, ABC, or in the PF units. So that where we can implement it and control the temperature, right? So this is what we can say that this is going to help in the combustion technology. Apart from if we are going to use this, what we can say the catalyst reductions, right? So for that we have the implement what we can say the systems for the NOx. So just I'm going to show how it is going. Yes, here I have just what we can say the DNOx system or DNOx technology is using in the what we can say in the water valve, so that inside here in the inside it is going to spray, right? So this is what we can say the air lens air cooled lens is it is installed because it is continuous going to and live in the what we can say the furnace exposed temperature exposed area, so that it is not going to harm. So it is made of the SS, and always it is having the lens of the air cool. Second is what we can say the urea deposition lens we have, and GFD module for the boiler and injection of the reagent we do, so that here we are going to spray the, what we can say the selective catalyst reduction technology we are using here, and we are going to do this ammonia as a spray. So if I'm going to show you what we through the this pressure part assembly drawings in place of where we are going to place these nozzles. So just from the what we can say from penthouse, we are inserted this lens, and also from the what we can say from your front panels, front water valve panels on horizontal direction, we have placed these nozzles. So just have a little what we can say the analysis and the data on the calculation basis, that if we are going to what we can say how suppose from 450 to 300 milligram per nanometer, if you are going to reduce, then we are going to what we can say reduction in the NOx is 2193 ton. If we are going to implement from 450 level from 450 to 100, then we are going to reduce of NOx of 3066 ton. So this is what we can say going to much what we can say is more effective ways. Now I'm just going to little one and two things I'm going to explain about the about what we can say the LOI management in the boiler. That suppose we are having the, what we can say the higher LOI, then we can do the what we can say through the recycle of first filled fly ash to the bunker, or high LOI filled with the coal, that we can do, so that more and more carbon we can burn it again. The second lucrative solution for right now in most of the in India, in the thermal power plants, we are using the biomass, bio brigades we are using. So this is also going to help to reduce the what we can say the emissions that is about, because for same 1 kilowatt of the generation of power, right? This the through the biomass, it is going to only 0.4 to 0.6 kg of the CO2 is going to emit. Right. So why this thing is going to be happen? Because in the what we can say as comparison of this biomass for same GCB of coal. Suppose I'm going to talk the tell the 1 kg of coal with the 3,500 GCB, and for same amount of what we can say the GCB of biomass, we are having the less carbon, and due to higher of the VM in the biomass, our emission is just only 0.4 to 0.6%, or what we can say, if we are going to 5% of blend with this biomass, we are going to reduce the 1.5% of the total emission in India, right? So that's why the government is giving the more emphasis of this bio brigades, biomass feeding in the boiler. So that's why the government of India has started this the biomass mission to implement. So right now for 20 just I am going to recall the date of 2022, they have set the target of the what we can say 5% of the biomass with the use of this co-firing. Another very lucrative solution for the green hydrogen, although it is not implemented anywhere, but it has the lots of potential in aspects of this environmental solutions, right? So we are right now facing the problems of the global warming, pollution, carbon neutrality, and greenhouse gases. These all are going to solve through the green hydrogen uses, right? Why? Definitely because just you see these slides. So if I am going to burn off 1 kg of carbon, then it is going to generate the heat of 8,084 kilocalorie. But if we are going to burn off 1 kg of hydrogen, then it is going to give the 28,922 kilocalorie per kg. So this is the figure is clearly indicating that the use of hydrogen, we are able to get the higher and higher amount of the energy. So, and because just we on what we can say running with the time, but the topic is very what we can say interested. So if you are not going to implement right now the legislation and this stringent norms and what we can say this the equipments which are going to help for the emission controls, then one day we are not very far from this condition, right? So this is the time that we have all together we have think in this point. So this is my vision from this platform that I'm going to urge to all of you, that definitely we have to save our environment. If our environment will be safe, we are safe, right? So thank you to all of you. Thanks for your patience. Thanks to you all of you lovely audience, right? So just right now I'm just going to open the session, so that if you have any query, then you can put here. And once again I'm thank you to all of you, because some participants are here are joined from the abroad. So thank you for showing the belief in this IEI seminar. Thank you.
Thank you, Dinanath. Thanks a lot for a very interesting session. Few participants have some doubts. Can we start discussing this doubt? Few questions are with Mr. Umesh Mate also. Umesh ji, are you there?
Yes.
Okay, no issue. Let me start with Dinanath ji. Dinanath ji, Mr. Nirav Givaria is asking that can you please more elaborate about low NOx burner, NOx burner?
Yes, definitely, sir. The low NOx burners, what we can say as per this design, it is having the what we can say the stages wise and swirling effect. The swirling effect, what we can say, we have studied as the basic of the combustion, that is triple T, time, temperature, and turbulence. So these things is going to elaborate in this what we can say the low NOx burner, where we are going to implement the combustion in a stages wise, or what we can say the basic funda of the NOx generation is when your combustion chamber, either you take the combustion chamber of the gas turbine, either you take the combustion of what we can say the PF boiler, wherever your temperature, right, your temperature is going beyond of 1050 degrees Celsius, or what we can say 1100 degrees Celsius, NOx is going to be formed. Right. So it is only the going to low NOx burner is what it is going to help, that it is going to modulate in such a way that your temperature is and combustion, the temperature is not going to beyond of that limit.
Okay.
There are several what we can say the vendors and suppliers are there. So accordingly, what we can say the design of swirlers, the designs of the stages are different. But basic funda regarding the low NOx burner is this one.
Okay, okay. Thank you. One more question from Mr. Manish. That is there any norms for velocity of flue gas to be maintained?
The velocity, what we can say for velocity is not directly going to impact for the what we can say the emission, right? Because the velocity is going to contribute and going to analysis for with the CFD, and it is much more important for the boiler design, right, sir? Because ultimately the thing that we need, that first our system, what we have designed of the boiler, what we have designed of the burner, what we have designed of the combustion chamber, that must first they have to produce their output, right? And the second thing is about that is coming for that, suppose how we are going to control this this factor, right? So
Okay.
for velocity is not going to what we can say in the coming in the figure for the norms.
Okay, okay. There are many questions due to the time limitation. We are not able to include all that. But let me have a last question. The question is that what are the advantages and disadvantages of feeding biomass?
Yes, it is a great, sir. It is a great, sir. And thanks for this question because I'm much interested. And right now I'm having working with the NPTI and the government of India that we have to enhance this biomass, right? So yesterday they have given me one assignment that I have to do one national workshop on the biomass, right? Biomass mission. So why the government is emphasis on why they have set up a mission for biomass, that it is going to help to control the emission, right? It is the technically one thing. I'm just in the one single line. I'm going to that make you the differences between the both. Suppose you are going to burn the coal, right? Okay, and you are have the target of generate the one unit of electricity means 1 kWh, right? So 1 kWh, you are suppose you are generating, suppose you can say 5 kg of CO2 you are going to burn, right? 5 kg of CO2 you are going to generate. But in case of biomass, you are suppose you are for same amount of generation of electricity means the output is the same. But if you are using the biomass, this value is reduced to 50%.
Okay.
So that's why the government is going to enhance, the government is making the norms and regulation to implement by forcing that this is the advantage. Apart from that, I'm just going to tell you the two important things. Government is also giving the what we can say the incentive for that. Because it is a best tool. Suppose
so
it is coming as a what we can say the residual of agriculture, right? But if you are not used, then their deformation is in the process. Definitely it goes and it is going to convert into the CO2, right? Definitely, no, there is no any other way. But if you utilize as energy sources, then it is what we can say it is treated as a gold.
Okay, okay. So I must conclude that Dinanath ji, it's a very sustainable tool for a thermal power plant nowadays if we can use biomass as a fuel. So thanks a lot, Dinanath ji, for delivering the very interesting topic about environmental legislation challenges and opportunities, as well as Mr. Umesh Mate ji for the topic desulfurization in thermal power plant. Moving towards the end of the session, our honorable president, Mr. Dr. H.O. Thackeray, Dr. N.T. Ranga Reddy, Chairman, Mechanical Engineering Division Board, Dr. G. Ranganath, Chairman, CATE, Dr. Jignesh Vagasia ji, Chairman of our South Gujarat Local Center, IEI, our most valued invited panelist, Dr. Dinanath Akela ji, Mr. Umesh Mate. Ladies and gentlemen, it's my privilege to have been asked for a vote of thanks on this occasion. Myself, Professor K.D. Panchal, Honorable Secretary, Institutions of Engineers, South Gujarat Local Center. On behalf of our whole team of South Gujarat Local Center and on my own behalf, extend a very hearty vote of thanks to all the speakers for gracing your important work, for your important experience and case studies, sharing with us with deep knowledge and opinions today. I may like to express my sincere thanks also to our respected President, Dr. G. Ranganath, Dr. N.T. Ranga Reddy, Mr. Kirti Setnaji, our past chairman, Mr. Jitendra Saxena, our valued Mr. Kingsuk Sen, who is Assistant Director and who is already constantly providing technical support for existence of this technical webinar, for their valuable presence during the entire session. Respected Chairman, my dear panelists, ladies and gentlemen, once again, I want to state that we are most grateful to all panelists on this stage. We thank you all the participants for being with us this evening. It's been a really great pleasure. Thank you everyone. Jai Hind, Jai Bharat. Thank you.
So thank you to all of you. Now we are just sign off the today's session, and hopefully this session is definitely give you some good impact to all of you and advantages of this technical webinar. So thank you to all of you.